for binary trees, within the general category of depth first, there are subcategories. So I'm going to construct the best example that I know for why these ideas are important about traversal, which was the parse tree that was like this that I showed you before. Okay? So now, to parse this depth first, for each node, there are basically 3 steps. There's print the node, there's do the left child, and there's do the right child. Right? Those are the 3 steps. Well, we can do those 3 steps in basically any order. People always do it left to right. People who speak English, which is a left to right language, always do it left to right. I have no idea. Maybe if you're a Chinese computer scientist, you do it right to left. Anybody know? Anybody follow Chinese computer science? Anyway, it doesn't matter. For our purposes, we're going to go always left before right. And that reduces the number of interesting possibilities to 3. And the 3 possibilities are, in order, which is left, datum, right. And that gives you 3 plus 4 times 5, right? First I print the 3, then I print the plus, then I do an in-order traversal here, which means first the 4, then the times, then the 5. So that's in order. Next we have pre-order, also very interesting, where we say datum, then left, then right. That gives us plus 3 times 4, 5, which 2 months ago you might not have thought very interesting, but now you can see is sort of the center of the universe. And then finally, we have post-order, where we say left, right, datum. I think I showed you this actually, which gives us the peculiar result 3, 4, 5 times plus. For human purposes, that looks pretty bizarre, unless you have an HP calculator, in which case you're accustomed to it and you understand the merits. But if you're a computer and you're running a PostScript, you're running a PostScript file to be printed, or JavaScript, do I have that right? No, JavaScript is prefix. Some language or other that's postfix. This is what you do. You get the data ready first, and then we say, what operator do I want to do? So this order, although it looks funny, is the order in which a computer actually carries out the computation. So we say 3, put that on a stack. A stack is the opposite of a queue. It's last in, first out. So take my 3, put it on the stack. Take 4, put it on the stack. Take 5, put it on the stack. Oh, look, an operator. Let me pop 2 things off the stack and use them as the arguments to times. And that gives me, of course, 20, which I push on the stack. And then, oh, look, an operator. Let me take 3 and 20 and give them to plus. So that's a really useful way to have things represented from the point of view of a computer. So those are the 3 sub-possibilities within depth first for binary trees.